You'd think that to study the conditions of space, you'd have to, go to space. But what if I told you some of the most important space research actually happens 500 feet underground in Cleveland, Ohio? In this explainer, we're going to unlock the secrets of how scientists create microgravity right here on our own planet.
So it all starts with a question that seems pretty simple on the surface. How does fire burn without gravity? I mean, we see fire every day, we think we get it, but you take gravity out of the equation and suddenly fire behaves in a completely alien way. And figuring this out isn't just for kicks, it's absolutely essential for keeping our astronauts safe up there.
Okay, so check this out. Here on Earth, gravity creates this constant cycle called convection. Hot air rises, cooler, denser air gets pulled down, and that whole process continuously feeds the fire with fresh oxygen, giving it that classic teardrop shape we all know. But in space, there's no up or down, so the flame just becomes a sphere. And without convection to clear away its own smoke and bring in new air, it basically just suffocates on its own exhaust. It turns into this dim, blue ball and then, poof, it's gone. So to study that without spending millions of dollars launching a rocket for every single experiment, NASA needed to get creative. And they found their answer not by looking up at the sky, but by digging deep into the ground.
And here it is. Welcome to NASA's Zero Gravity Research Facility. From the outside, it looks pretty unassuming, right? But it's hiding this incredible secret, one of the most unique labs on the entire planet, dedicated to simulating the final frontier.
The scale of this thing is just mind-blowing. We're talking about a 510-foot deep vertical shaft that's taller than a 40-story building with a massive steel vacuum chamber inside. And its whole purpose, its only reason for existing, is to drop something in a state of perfect, uninterrupted freefall. And freefall, that's the magic word. See, when something is falling without any air resistance, it experiences weightlessness, or microgravity. The real challenge is, how on Earth do you create a perfect sustained freefall on Earth? For exactly 5.18 seconds. Now, I know what you're thinking, 5 seconds, that's it? But for scientists who are capturing thousands of data points every single second with high-speed cameras, those 5 seconds are an absolute goldmine. It's more than enough time to see how fire spreads, how liquids slosh around, and how materials react the instant gravity just disappears. The whole drop process is just a masterpiece of engineering. First, they seal up the experiment in this protective vehicle. Then, and this is the really critical part, they pump all the air out of that giant steel chamber to create a vacuum. No air means no air resistance, which means a pure, perfect freefall. Then they just release it. For those 5.18 seconds, all the cameras and sensors on board go absolutely wild, capturing everything. And at the bottom, it's caught safely in this big deceleration cart. Pretty cool, right? But what about places that have some gravity, like the moon or Mars? Well, they can simulate that too. The lead engineer, Victoria Valletta, explains it perfectly. She says if you've ever been on one of those gravitron rides at an amusement park that pins you to the wall, it's the same idea. By spinning the experiment as it drops, they can create a force that perfectly mimics the gravity on the moon, or Mars, or anywhere in between. And believe it or not, this facility isn't new. It's been the quiet, beating heart of America's space program for decades, solving huge problems for some of the biggest missions in history. I mean, this facility's legacy is literally woven into the story of American spaceflight. Back in the 60s, it helped figure out how to restart the Saturn V engines on the way to the moon by studying how fuel sloshes around in zero-G. In more recent years, its research was absolutely vital for fire safety on the International Space Station. And today, it's paving the way for the Artemis missions, making sure our next generation of lunar explorers will be safe. And this is why this ground-based testing is so unbelievably important. Researchers here actually found this weird Goldilocks zone where some materials burn more intensely in the moon's partial gravity than they do in zero-G or full-G. Finding that out in a 5-second drop here on Earth saves millions of dollars and, way more importantly, it protects our future astronauts. It changes how we design their habitats before a single part is even built. Of course, a facility this incredible is still just a building. It's nothing without the brilliant, dedicated people who run it, the ones who turn a 500-foot hole in the ground into a gateway to the cosmos. For someone like Victoria Valletta, working here is literally a dream come true. She talks about overcoming that feeling of imposter syndrome through just pure hard work and dedication. Her story is such a great reminder that behind all of this amazing science are passionate people putting in the time, solving impossible problems, and pushing all of us forward. So, in the end, every single drop they do here is so much more than just data on a screen. It's the result of countless hours of effort, a deep passion for exploration, and the fulfillment of that childhood dream to help humanity reach for the stars, all captured in 5 incredibly precious seconds.
And that just leaves you with this fascinating thought. For over 60 years, this place has been answering questions we didn't even know we needed to ask. So it really makes you wonder, what other secrets of the universe are we going to unlock? Not by looking up at the stars, but by simply dropping things down a hole right here on Earth.